Okay, welcome again to another session. The lesson of today is about from physics from 2 class, and the topic is motion in straight line. But here we are going to deal with the Newton's equations of motion. The Newton's equations of motion. First of all, you are supposed to know who is the founder of these equations of motion. It is explainable that Sir Isaac Newton was the founder of those equations. And those equations, special ones, are an object or body moving in horizontal motion. So, apart from that, let us start to analyze those 3 equations. So we have 3 Newton's equations of motion. We have three Newton's equations of motion. Let us go directly to those 3 Newton's equations of motion. The first one we call Newton first equation of motion. The second one we call Newton's second equation of motion. But the third one we call Newton's third equation of motion. As I said that Sir Isaac Newton tried to realize or to explain 3 equations. One is the body moving in horizontal motion in 1886. So now, here we have 3 equations. The first one is Newton's first equation of motion. We have Newton's second equation of motion, and we have the Newton's third equation of motion. Let's start with the first one. The first one we call Newton first equation of motion. The expression for the Newton first equation of motion is expressed as follows, which is V, this is equal to Vi then plus It. So this is the first equation of motion, which have been explained by Sir Isaac Newton. But this V represents the final velocity. You can write Vf. But Vi represents the initial velocity. A represents the acceleration, and T represents the time. But we are going to derive the formula of the Newton first equation of motion. So in order to prove this formula, or to show this formula, as we are supposed to start as follows. Let it concerns, you start, or let us write the proof first of all. We are supposed to prove the Newton first equation of motion. We say that proof after writing proof, we come to another thing, which is like it concerns or it relates. It relates with, you start on information. We have final velocity. So it relates with final velocity, which is Vf, comma, also you have initial velocity. Right here, initial velocity, which is Vi, comma, we have acceleration, which is A, comma, also we have time, this way, time t, Apart from analyze the thing which is very important so as to prove or to derive the formula for the Newton's first equation of motion. Now we are going to search the formula for acceleration after analyzing the thing which is very potential so as to derive our formula to prove our Newton's first equation of motion. So after analyzing the main things or the main concepts which need so as to prove or to show the Newton's first equation of motion, let us go directly to see the definition of acceleration. We have said that acceleration actually is equal to, we take the change of velocity then you divide it by time. After writing this formula, we are supposed to multiply out multipliers. Once you multiply here, we take A times T. You get A times T. This is equal to 1 times change of V. 1 will be equal to change of V. So now change of V, this is equal to A T. But remember that when you say change of V, means that we assume that where a body starts, which obeys the potential, means at rest, we call it initial velocity. But when a body starts to moving or starting moving, it not obey the initial velocity, it obey the final velocity. So if it is obey the final velocity, means that where there is change of velocity, we have the final velocity and we have the initial velocity. So now we say change of velocity, this is equal to final velocity then minus the initial velocity. Then we are going to insert here where there is change of velocity. We take its value, then we substitute where there is change of velocity. Then it is equal to from here. AT, this is equal to, instead of writing change of velocity, get final velocity minus the initial velocity. Final velocity minus the initial velocity. But according to our formula, which expresses the Newton's first equation of motion, it is starting with Vf. So here now you are going to make it Vf from this expression or from that equation. So in order to get the Vf, we take this one, then we shift it to this side. So it means this side remains with Vf, this is equal to AT, then this is negative. But after crossing the equal sign, the sign of it will be changed and to be positive. So it's plus Vi. Then Vf, this is equal to, remember here, Vi is the start, then AT will be the next. So we start writing V and then plus IT. So this is the first equation of uniform motion, or the Newton's equation of motion. So we call this is the first one. First equation. First equation. Whereby. So once, remember, you need all we are required to prove. Then you write hence proved. Hence proved. Hence proved. So this will be the answer for driving or proving the Newton's first equation of motion. From our Newton's first equation of motion, now we say where Vf, this representing final velocity. Final velocity means that the final velocity after the body starting moving. But when the body just existing or just potential means does not moving, that velocity we call initial velocity. And actually, initial velocity is always in 0 meters per second. Then Vi, the next symbol here is initial velocity. So we write initial velocity this way. But A, there is A here to a formula. There is A. A represents the acceleration. Acceleration. Then T. T represents the time. Now let us see the second or Newton's second equation of motion. Newton Newton's second equation of motion. The Newton's second equation of motion, it is expressed as follows. S, this is equal to VIT plus half AT squared. So we are going to prove this one, this is formula, or the second equation of motion. Yes. After writing the expression of second equation of motion, let us go to prove it. So let us already prove. Oh, sure. After writing the already proof, just write the requirements or the main thing which needed so as to prove the second equation of motion. First of all, we have displacement or distance. So its rate, you write it is rate, its rate with one displacement, which is s. Also, it relates with the initial velocity. Which is vi. Also, it relates with time, which is t. And it relates with the acceleration. A. Then apart from that, after analyzing the main thing which needed so as to drive or to prove the second equation of motion, we come directly to the formula for determining the average velocity. So that from average velocity. When you say average velocity, it is simply AV, means average velocity. This is equal to, we have two formulas to determine the average velocity. We have initial displacement plus the final displacement. Then you divide by the summation of time taken. But once we have the initial velocity and we have the final velocity, maybe, how we can obtain the value of average velocity or the formula? We check that. If we have initial velocity and the final velocity, we say that average velocity is equal to find the summation or total of initial velocity, which is vi. Then we plus the final velocity, which is vf. Then we divide it by 2. Once you check it, is abbreviation of average velocity, which is equal to AV. This is equal to initial velocity, which is vi. We write here vi, then we plus final velocity, vf. Then we divide it by 2. After reaching to this point, what are we going to do? We say that average velocity is equal to velocity, and the formula for velocity is equal to displacement over time. So where there is average velocity or velocity here, you are going to substitute s over t. So we write s over t. S over t, this is equal to this one. Vi, then plus Vf, then we divide it by 2. From, you have a Vf from the first equation of motion, from the Newton's first equation of motion, which is stated that Vf, this is equal to Vi, then plus At. Here we can let it to be maybe the equation 1. So from the first equation of motion, which is stated that Vf is equal to Vi plus At. We are going to substitute the value of Vf, which is Vi plus At, here to our equation 1. So we are going to substitute the value of Vf, which is Vi plus At, to the Vf here. So we start to write this side S over T. This is equal to Vi, then plus this one. After instead of writing Vf, we write its value from the first equation of motion, which is stated that. So instead of writing this Vf, we write its value to the price Vf. So instead of writing Vf, we write Vi, then plus At, then divided by 2. Therefore, Vi plus Vi we get into Vi. So S over T, this is equal to 2Vi, then plus At, then divided by 2. This is equal to, somebody writing like this way. Yes. This one. Remember, 2Vi and At, they share the same, the common LCM. So once two or more numbers share the common LCM, you can write like this way. For example, assume that you have A plus B over C. This is equal to another set like this way. A over C, then plus B over C. So once you look here, it's in form of this one. So we can write in form of this one. So S over T, this is equal to, we start to separate there. 2Vi over 2 plus At over 2. After reaching here, what are we going to do? We are supposed to multiply by T both sides. So when you multiply by T, T and T cancel. Then S, this is equal to, then opening the bracket, we start 2Vi times T. We get 2ViT, then over 2 plus this operation. Come again, At times T gets At square over 2. Then 2 and 2 cancel. So remaining S, this is equal to VIT, then plus At square over 2. Once maybe somebody writing that maybe X, means that the coefficient of it here is 1. So even as here we can write 1, but no problem, or it is not necessary. So S, this is equal to VIT, then plus a half At square. So once you look this formula, it look like the second formula, which I've deleted it. So we can write now hence proved it, and this we call the second equation. The second equation of motion. Yes. After proving it, we started to express the meaning of the symbols found into our formula, which is S. This represents the displacement. Displacement. Whereby VI, this represents the initial velocity. Velocity. C representing the time, and A representing the acceleration. Yes. Let us see the third equation. 3. Newton's study equation of motion. which is it expressed as vf square. This is equal to vi square then plus 2as. So this is the expression for the Newton-Standard equation of motion. We are supposed to prove it. So you write the word proof. After writing the word proof, we say it relates with a VF, VI, acceleration, and a displacement. The sum applied. Or we can write it relates with initial velocity, which is VF. This is VI, initial velocity. Then final velocity, which is VF. Also acceleration, which is A, and the time T. Then after arriving the main thing or the common thing here needed so as to prove the third equation of motion, we say we write from the first equation of motion, which expressed as VF. This is equal to VI then plus AT. Here we have different tips so as we can use so as to achieve or to prove our formula. We have several ways, but let me show one among of it or two. We can start. We can write by squaring both sides. Now we are going to square both sides. Which is this first equation. So here will be equal to VF. This is equal to VI then plus AT. Once we are trying to square both sides, you can square this way. Once we square that way, we get VF square. This is equal to, now we have to expand this one, which will be equal to VI plus AT, then VI plus AT. After expanding it, we are supposed to open the bracket. Then VF square, this is equal to, we start VI, make sure that this VI multiply all of the elements formed in this bracket. So we start VI, then we multiply all values, all terms from this bracket, which is VI plus AT, then you put in bracket. We come to the next term here, which is just writing first the operation formed to these two terms, which is plus, then write 80, then in brackets. Make sure that 80 also multiply the whole terms from this bracket. So VI then plus 80. After that, we start to open the bracket. So VF square, this is equal to VI times VI get VI square. VI square. Then plus VI times 8 you get VIT. VIAT. Then we plus again. 80 times VI, we get VIAT. Then plus 80 times 8 you get A square, then T square. Then we proceed. VF square, this is equal to VI square, then plus. Here we have VIAT. VIAT. Once you find the summation here, we get 2 VIAT, then plus A square, then T square. Yes, from here now, which is VF square, this is equal to VI square, VI square, this one. Then plus 2 VIAT, then plus A square T square. What are we going to do after reaching to this point? Now here we are going to deal with this side only. So, but once you write starting to this value, which is V F square is equal to V I square, then plus. Here we are going to factor out to A here. After crossing the bracket of these two terminals or these two terms, we are supposed to factor out to A outside. So we write here factor out to A here on this side and not this side. So just deal with these terms only. So we factor out to A. Once we factor out to A, to this term and this term, then you take this term, then you divide by 2A. Then 2A will cancel. So remain with VIT, then plus. Then you take this one, this term, you divide to this factor. Then A, here we have A2, here we have a single A. So this one and this one will be over. We remain with one on A. So, but 2 also will remain. I mean that. When we take A square, then T square, we divide by its factor, which is 2A. A and A are cancelled. So it means A T square over 2. Now we write here A T square over 2, that is this way. But from the second equation of motion, which is stated that S, this is equal to VIT, then plus AT square, then divided by 2. But once you look at this one, it's similar to this one. This one is similar to this one. So instead of writing VIT plus AT square here, you're going to write only S here. Because the value of this one and this one are similar or are equal. Then you start writing from this side. VF square, this is equal to VI square, then plus 2A, this one, 2A. So instead of writing this whole terms, you are going to use it is meaning, which is S. So instead of writing VIT plus AT square over 2, VIT plus AT square over 2, you're going to write S. So instead of writing this one, we're going to write it on our AC. So we take the S, then we write it here. So it is equal to S. So now, VF square, this is equal to VI square, then plus 2AS. And this one looks similar to this one. So then we write it, hence, alright, first we write here the steady equation. The steady equation. Then you write hence proved. Hence proved. This way. Where S this is VF. VF will represent the final velocity. This is V. This is the final velocity. Then you have VI, which represents the initial velocity. Then we have A. This one A, representing acceleration. Also we have S. S represents the displacement. We have several methods to prove the steady equation or the Newtonian steady equation of motion. But this is this one, which I have used it, is the amount of that way. So you can use this one so as to achieve your proofing, or you can use this alternative. Now let us see alternative method for proving the steady equation of motion. Okay, let us see alternative method, which you can use so as to prove the Newton's third equation of motion. This is in order to prove the third equation of motion. You start from the first equation of motion. From the first equation of motion, which expressing as Vf is equal to Vi z plus At. The first way to do here, you're supposed to shift this one to this side. So that Vf now minus Vi, this is equal to At. Then after reaching here, divide by A both sides. So we are going to divide by A, divide by A. After dividing by A both sides, we get this one and this one cancel. So when we T, this is equal to Vf minus Vi over A. That is this one to be the first equation. Then you come to the formula for average velocity. Also, you come to the formula of average velocity. Average velocity is equal to, we take the summation of Vf, then Vf and Vi, then you divide by 2. But here, AV means average velocity. This is equal to velocity. This is equal to AC out of T. Then from here, which is AV, this is equal to AC over T. So we are going to substitute AC over T here. AC over T here. So we say AC over T, this is equal to, we take this one, then you substitute where there is AV. Is equal to Vf plus Vi over T, which is Vf plus Vi over 2. This way. Once we come to multiply by T, so T and T will cancel. So then S, this is equal to Vf plus Vi divided by 2, then times T. But what is T? From our first equation here. Our first equation is the value of T is Vf minus Vi over A. Vf minus Vi, then over A, this way. Then we started to multiply. So S, this is equal to Vf plus Vi. Then you're going to multiply with this one. Vf minus Vi. Then you divide by 2 times A, you get 2A. Then after reaching to that point, we are supposed to multiply by 2A both sides. Once you multiply by 2A both sides, this 2A and this 2A cancel. So you can use 2A times S this side. This is equal to Vf plus Vi. Vf minus Vi. Once you consider this one, we go directly to the concept of different two squares, which is it's such the concept of two different squares, which is that once you given a squared, or let me try this. A squared minus b squared, this is equal to a plus b, then a minus b. So this one in form of this one. So as we are supposed to convert it, or we are supposed to write in terms of this way. So After writing this one and after inserting the concept of two different squares, we write 2. Once we find the product here, we get 2as. 2as. This is equal to. This will be equal to. Remember, we have two variables here. We have vf and vi. So it will be equal to vf square then minus vi square, according to the concept of two different squares. Then we shift this one to this side. Once we shift this one to this side, remains 2as, then plus. Remember, it have ought process negative. After crossing the equal sign, it is equal to positive. So it is equal to vi square. This is equal to vf square. So vf square. This is equal to vi square. Then plus 2as. Then right answer shown, because this one we say this is the second. The third equations are of motion. Then thank you for watching.
Can anybody out there hear me? Hear me?